For f of x is equal to x plus 3 squared minus 4, we've been asked on this problem to find the vertex, the axis of symmetry, the y-intercept, and the x-intercepts. Now, this particular parabola is already in standard form for a parabola. Since it is, the vertex of the parabola is the opposite of what is in the parentheses for the x value and the same as what's on the outside for the y value. So to find the vertex of it, opposite of positive 3 is negative 3. Same as what's on the outside, negative 4, and there is our vertex, negative 3, negative 4. Now, since the parabolas will deal with only open either up or down, that means that the axis of symmetry will be the vertical line that goes through the vertex of the parabola. Vertical lines are always x equals a number, so for the axis of symmetry of this one, x equals negative 3, since negative 3 is the x value of the vertex. The x value of the vertex gives us where the axis of symmetry will be, and it should be written as an equation, x equals negative 3. Next, let's find the y-intercept. Now, just like with every other problem that we've done, to find a y-intercept, we put 0 in for every x, and then we do whatever arithmetic results. So let's take 0 and let's put it in for this x. 0 plus 3 makes 3, and if we square it, we'll have 9. 9 minus 4 gives us 5. So 0, 5 is our y-intercept. 0 for all the x's gives you a y-intercept. The x-intercept's a little bit harder for us to get. We'll put 0 in for y. In this case, it's an f of x. So 0 in the place of y gives us this equation for us to solve. There are lots of different ways we could solve it, using the quadratic formula, perhaps factoring, but the easiest thing for us to do is what is called the square root principle. Let's first take the minus 4 that is at the back and move it across the equals to the other side. When I move it across, it's going to become a positive 4 when we move it to the other side. Now, to get the x to be isolated, the first thing that I'll do is get rid of this square by taking the square root of each side. Now, usually a square root we just think of as being a positive solution, but remember, things that have a degree of 2 should have 2 solutions. To account for having 2 solutions, we'll do the principal square root of 4, which is positive 2, and we'll also do the negative square root of 2, which is negative 2. So plus or minus 2 equals the stuff in the parentheses after we've taken the square root of each side. Now, this will give us 2 separate equations for us to solve. We can say, what if this x plus 3 is equal to positive 2? Then we can say, what if this x plus 3 is equal to negative 2? So here are our 2 equations. X plus 3 equals 2, or x plus 3 equals negative 2. For both of these, let's just move the 3 across by subtracting. Subtracting 3 here, 2 minus 3 gives me negative 1. Subtracting 3 over here, minus 2 minus 3 gives me minus 5. Now, these are the solutions for x, but if they are x-intercepts, the y value of an x-intercept is always 0. Remember, that's what we substituted for y back at the start of the problem. So our 2 x-intercepts then are negative 1, 0, and negative 5, 0. That's where we're crossing the x-axis.